Have you ever wondered how we recycle metal? It's a fascinating process that goes beyond just aluminum cans. Not just aluminum cans, but giant chunks of steel. These massive pieces of scrap metal are given a new life. That's where electric arc furnaces, or EAFs, come in. They play a crucial role in the recycling process. Imagine a giant pot, we're talking big enough to fit a school bus inside, that uses electricity to melt metal. It's an incredible sight. That's an EAF. These furnaces are marvels of modern engineering. Inside the EAF are giant power wands called electrodes. They're essential to the melting process. These electrodes are made of a special type of carbon, kind of like a giant pencil lead, but much more powerful. They're super strong and can handle incredible heat. The temperatures they reach are astonishing. These electrodes are the key to melting all that scrap metal. Without them, the process wouldn't be possible. But how do they do it? How do these electrodes turn scrap into molten steel? Well, let me tell you, the process is both complex and fascinating, involving intense heat and precise control. Picture this. You have a battery and you touch a wire to each end. Instantly you see a small spark. This simple experiment demonstrates the basic principle of creating an electric arc. Zap! You get a spark. This tiny spark is just a miniature version of what happens in industrial settings. That's basically what happens in an EAF, but on a much larger scale. Imagine this process magnified thousands of times. When the electrodes are lowered into the furnace filled with scrap metal, they don't actually touch the metal right away. Instead, they hover just above it. Instead, they create a gap. This gap is crucial for the next step in the process. Electricity flows through the electrodes, and across this gap it creates a powerful electrical arc. This arc is the heart of the melting process. These arcs are like miniature lightning bolts. They are incredibly powerful and bright. They generate intense heat reaching over 3,000 degrees Fahrenheit. That's hotter than lava. This extreme temperature is necessary to melt the scrap steel. This incredible heat melts the scrap metal, turning it into a pool of liquid metal. The transformation is mesmerizing to watch. It's like watching a giant metal soup being cooked. The molten metal is then ready to be poured and cast into new shapes, continuing the cycle of metal recycling. Now, controlling these powerful arcs is crucial. The electrodes need to be carefully positioned to maintain a stable arc. If they are too close, the arc will be short and unstable, like a flickering candle. Too far and the arc might break altogether, wasting energy and interrupting the melting process. That's why EAFs have sophisticated control systems that constantly adjust the height of the electrodes. These systems monitor the arcs and make tiny adjustments to keep them just the right length. It's like a delicate balancing act, ensuring the most efficient and stable melting process. Precise electrode regulation is essential for efficient and safe steelmaking. The electrodes must be carefully adjusted to maintain the right temperature and arc stability. This precision ensures that the steel melts uniformly, avoiding any weak spots or inconsistencies in the final product. By maintaining stable arcs, EAFs can melt scrap metal quickly and use less energy. This efficiency not only speeds up the production process, but also significantly reduces the overall energy consumption, making the process more sustainable. This is good for the environment and helps keep steel production costs down. Lower energy usage means fewer emissions, contributing to a cleaner, greener planet. The cost savings from reduced energy consumption can also be passed on to consumers. Perfect electrode control also ensures the safety of the operators. Properly regulated electrodes prevent dangerous fluctuations in the arc, which can lead to accidents or equipment damage. By preventing erratic arcs and electrical surges, the risk of accidents is minimized, making the whole process much safer. This stability is crucial for maintaining a safe working environment in the steel mill. So the next time you see a bridge, think about the precision and technology that went into creating the steel components. A car or even a building, remember the intricate process behind the scenes. Remember the incredible power of electric arc furnaces. These machines are not just melting metal, they are shaping the very framework of our modern infrastructure. These amazing machines with their giant power wands and controlled lightning bolts are essential for recycling metal and building our modern world. They represent the pinnacle of industrial precision and efficiency, driving progress and innovation.